Hello and welcome to the Data and Database Administration video lecture. In this summary lecture, you will learn about the basics of the data and database administration. Database administration is the vast subject and typically requires its own dedicated course. However, in this chapter and your book, you will only be introduced to the fundamentals. If you are interested in becoming a database administrator, you will need to enroll in a professional certification programs for each specific database system which you would like to manage. In this lecture, you will cover some basic topics, but remember, this is just a summary. To gain a better understanding of even these basic concepts, you need to read the book and complete the assignments and assessments provided. By the way, this is Hossein Mohit. In the previous chapters, you learned that data is the lifeline of any business. It is like the foundation of the business operations. Without the exchange, generation, and updating of the data, business activities becomes meaningless. In this sense, a database can be seen as the veins and heart of the business. If there is no database to keep track of this data, the business cannot be sustained. When it comes to data and databases, especially in larger organizations, we can distinguish between data administration and database administration. However, in medium and smaller organizations, these rules often overlap and are not clearly distinguished. There are some key differences between data administration and database administration. Database administration focuses primarily on the structural integrity of the data. It deals with the design of the database to ensure it meets business needs and optimize for future operations. Database administration, on the other hand, is primarily concerned with the safety, maintenance, and ongoing operation of the database management systems. In summary, data administration is more about designing the database well from the start, while database administration is focused on the ongoing maintenance and smooth operations of the database systems. Within the realm of data administration, identifying and describing data can be a challenging task. It requires a solid understanding of the business processes and cultural context. Therefore, a data administrator must have a deep grasp of the business and be able to capture business requirements and understand how data is used within the business context. A data administrator is also responsible for defining data standards and policies, which are the part of the data governance. Data governance focuses on determining what data should be collected, how it should be organized, and establishing standards of the data gathering and storage. It defines how each piece of data should be named and sets acceptable range of the data. The goal of the data governance and data policy is to ensure consistency in data structure and naming across the organization so different units use the same data definition and standards when designing their database and storing data. The data administrator is also responsible for creating metadata or data dictionary. Metadata is essentially data about the data. It includes variable names, definitions, acceptable ranges, and statistical measures like mood, uh, average, and standard deviation if applicable. This helps provide a clear understanding of the data being used. Another key responsibility of the data administrator is ensuring data quality and data integration. High quality data is accurate, complete, current, consistent, reliable, relevant, and accessible. It should be delivered in a format that is useful and easy to interpret. At the design level, the data administrator must ensure that these quality standards are met and that a single schema is used throughout the organization. This facilities This facilitates seamless data integration without significant errors or disruptions. The primary focus of the data administrator is during the design and implementation phase of the database. After these phases, the data administrator collaborates with the database administrator to design controls and maintain data integrity. In contrast to the data administrator, a database administrator or DBA focuses on more technical tasks and may not need an in-depth understanding of the business processes, cultural context, or specific user requirements. The primary responsibilities of the DBA revolve around managing the database management systems, and also, one of the challenges of the DBA might face is dealing with the different DBMS platforms within the same organization, which may need to communicate and work together. A significant responsibility of a DBA is to protect the database, which occurs at two levels: physical level and data asset level. Physical level protection ensure the physical uh, security of the database server, which includes controlling physical access and maintaining server backups. Also, managing hardware backups to prevent data loss in case of failures, and also protecting physical servers and databases from internal and external threats, including attacks and unauthorized access. The second one, the data asset level protection, it safeguards the data itself, resolving any programming errors and addressing conflicts within the database management systems. It also have a robust recovery plan for both natural and unnatural disasters, which include having consistent backup for both data and hardware components. In addition to security, the DBA is also responsible for ensuring high performance of the database. This involves striking a balance between providing a quick and efficient access to the data and maintaining strong security measures. The DBA must provide reliable and rapid access to data without compromising its security. Both aspects need to be considered simultaneously to ensure that the organization's data assets and database systems are secure and efficient. As I mentioned, database security has two main layers: physical security and data assets or data access security. Let's break down these concepts further. First one, physical security. This involves creating a secure physical environment for your database server. It includes controlling who can access the server rooms and ensuring that the only authorized personnel can enter these areas. It also involves having hardware backups, which protect your data in case of hardware failures or physical damage to the servers. This layer of security ensures that the physical components of your database are protected from threats. The second level, data access security. Data access security focuses on controlling who can access the data and what they can do with it. It is achieved through the authentication and authorization. Authentication is the process of identifying and verifying who or what need to access the data. This can involve checking user credentials such as usernames and passwords, or identifying authorized applications. Authorization follows authentication. Once you know who or what needs access, you define what part of the database they can access and what actions they can perform. For instance, certain users or applications may have read-only access, which means they can only view data, while others may have read and write access, which they can view and modify data. So you define users, rules, and roles and also permissions based on the level of access needed. For example, user group A can only read certain parts of a database. User group B can read and write to a specific table, but only has read access to other tables. Another important aspect of the data access security is encryption. Encryption involves coding the data so that even if someone gains unauthorized access, the data remains unreadable without the correct decryption key. This ensures that the sensitive data is protected and unauthorized users cannot interpret it even if they bypass authentication and authorization measures. In summary, the two layers of the database security work together to protect both the physical and digital aspects of the database. Physical security safeguard the server environment, while data access security focus on who can interact with the data and what they can do, often strengthened by encryption. When it comes to laws, regulation, and policies, database administrators, DBAs, and data administrators must work closely together to ensure compliance and effective management of data. Here is how they need to approach this. In the organizational level, at the most immediate level, administrators must ensure that database management system align with the overall organizational policies related to the data management and information systems. This means making sure that database design and operations follow the organization's data policy, governance rules, and security guidelines. For example, the database design should adhere to the organizational standards for the data consistency, naming conventions, and access control policies. In the industry level, beyond the organization, there are industry-specific regulations that DBAs and data administrators need to be aware of. These regulations are often set by professional associations or industry bodies to ensure standardization and interoperability uh, across the industry. Understanding industry norms and best practices is crucial. For instance, in the financial sector, database may need to meet certain standards for data encryption and audit logging to prevent fraud and ensure secure transactions. Regarding the government regulations, there are also government laws and regulation at the states or national level that database must comply with. For example, in the healthcare industry, database must meet the HIPAA requirements to ensure patient data privacy and security. Or for the accounting databases, compliance with the Sarbanes-Oxley Act (SOX) is essential to ensure the data accuracy and auditability of the financial records. It is the responsibility of the administrators to understand these legal requirements and integrate them into the database design and security measures. Regarding the international regulation, if the company operates internationally, additional international laws and cross-border data regulation may apply. For instance, the General Data Protection Regulation, GDPR, in the European Union has specific requirements for data privacy and user consent. In such cases, the company might need to implement different database policy or make adjustment to the database design to meet the legal requirements of each country. In summary, compliance with organizational policies, industry standards, and government's laws is crucial for effective data and database administration. Administrators must stay informed about the relevant regulations and work collaboratively to ensure that the database system meets all required standards, avoiding legal and operational risks. Concurrency control is a critical subject for database administrators, especially in the transactional databases. The issue of concurrency arises when two users or applications attempt to update the same table or data at the same time. Without proper concurrency management, this can lead to lost updates, uh, data inaccuracies, and even threaten the integrity of the database. To handle this, concurrency control mechanism ensure that updates are either committed or rolled back entirely. This guarantees that there are no lost updates and the database remains accurate. One common way to manage concurrency is through the ACID properties or ACID properties. ACIDs stands for atomic, consistent, isolated, and durable. So regarding the atomic, a transaction is indivisible. It is the smallest unit of work. Either an entire transaction is processed or none of it. There are no partial updates for the data. The database must maintain its rule and constraints before and after the transaction. For example, if a shopping cart's total amount must equal to the sum of its item prices, this rule must hold through before and after the transaction. Isolated transactions are processed as through they are running independently. This means that while a transaction is being executed, other users cannot interfere or access the data involved in that transaction. This prevents data conflicts. And the last one, durable, once a transaction is committed, it becomes permanent. Even if the database system failed immediately after the transaction, the changes made by the transaction are preserved. To implement concurrency control, most database management systems use a locking procedure. Locking involves temporarily restricting access to the data that is being updated, ensuring that no other users or applications can modify it until the current transaction is complete. This prevents error that could arise from simultaneous access and update to the same data. In summary, concurrency control is essential to maintain the accuracy and integrity of a database, particularly in environments where multiple users of applications need to access and update data simultaneously. The use of ACID properties and locking mechanism ensures that the database remains reliable and consistent even under concurrent operations. When implementing locking mechanism in a database, one important decision is that the level of granularity for the lock, which refers to which part of the database we choose to lock during a transaction. The options range from a database lock level, which locks the entire database, to the table level lock for a specific table, a viewed level lock for a specific view of a table, a record level lock for a specific rows, and even a column level lock for individual fields. The choice of locking level depends on the nature of the task. Higher level locks, like the table level locks, provide stronger atomic and consistent operations, but can significantly slow down performance because no other user can access the entire table while it is locked. In contrast, using a lower level lock, such as the record level lock, allows for more concurrent transaction and a smoother database operation since it only restricts access to a specific records rather than the whole table. Balancing granularity and performance is a key aspect of the database management. Locks can also be categorized as exclusive or shared. Exclusive locks, also known as write locks, prevent both reading and writing by other users because the record is being updated. Allowing other transactions to read the data during an update could result in showing incorrect or inconsistent information. On the other hand, shared locks, also known as read locks, allow multiple transactions to read the data but prevent any updates. Since the record is only being viewed and not modified, it can be accessed by many users simultaneously without causing data inconsistencies. The main trade-off in locking mechanism is between ensuring data integrity and allowing smooth concurrent access to the database. Exclusive locks guarantees that the data remains accurate and consistent, but they can reduce performance, especially when locking entire tables. Shared lock, while permitting more concurrent access, might not be suitable for tasks that requires updates. In complex transactions involving multi-tables and records, the locking strategy can become challenging. When multiple records across different tables need updates, the database must coordinate these locks effectively to prevent deadlocks, situations where two transactions are stuck waiting on each other, and to maintain data integrity. So the design and the implementation of the locking mechanism need careful consideration, especially in high transaction environments. In database management systems, having a solid backup and recovery plan is crucial. Data, as you have learned, is the lifeblood of any business. Losing data or the ability to process data, even for a short time, can result in significant financial losses, especially for the large businesses. It is essential to have a backup strategy in place and a clear recovery plan for what to do if something goes wrong and you need to restore the database. A good database management system should have at least three main procedures in place for data protection: backup, mirroring, and logging. Backups can be either cold or hot. A cold backups, offline backups, we also call it, is performed when the database is shut down completely. This method ensures complete backup, but the database is unavailable during the process. A hot backup or online backup happens while database is still operational, allowing continuous access even though changes are made during the backup process. There are other backup strategies like full backup, incremental backup, and differential backup, which you can read more about it in your textbook. Often, a combination of these methods is used to ensure there is always at least one up-to-date copy of the database. Database mirroring or disk mirroring is another technique where every change made to the main database is mirrored in secondary parallel database. If the main database fails, the mirror database can immediately take over, ensuring minimal disruption. Logging is another critical feature in the database management. A database log keeps a record of every change made to the database. It notes what changes were made, when they were made, which tables and records were affected, and who made the changes. This logging capability is vital because it helps restore the desktop to its correct state during recovery. If something goes wrong, the logs combined with backups and mirroring allow the database to be brought back to an error-free, fully operational state. Another key aspect of the database administration is performance optimization. Database administrators need to fine-tune various parameters based on the current business requirements. There are multiple ways to optimize performance, starting the memory optimization, ensuring that no excess memory is used, and disk optimization, making sure disk space is used efficiently. For example, choosing between varchar, which variable character type, and char, which is the fixed character type, can impact performance. We talked in the previous sessions. Varchar uses the less disk space for variable length data, but it might use more memory. Char use a fixed length, which can be more efficient in memory usage, but may waste disk space if the full length is not utilized. Deciding between these options depends on the specific needs of the situation, could be uh, have a different result. The query optimization is another critical part of the performance tuning. Writing efficient queries that meets the business requirements while minimizing the demands on the database can significantly improve performance. As a database administrator, your role is to balance these various factors to ensure the best performance and reliability for the database systems. So concludes our lecture on data and database administration. I hope you found it informative and gained some new insight. Remember, this was just a summary lecture. So to develop a deeper and more comprehensive understanding of the database administration, please make sure to read the relevant chapters in your textbook and complete all the assigned exercise. Good luck.